Okay, welcome back to the last lesson for polynomials. We are going to be looking at special factors, namely the difference of squares and the perfect square trinomials, okay? So first, there are 4 questions here for you to practice. I'll give you some time. Please pause the video and give it a try. I will show you the answer really quickly, okay? Okay, so this one, the answer should be x plus 16 times x minus 1. This one, you should factor out the 10. And then if you factor this, you should get x minus 5, x plus 2. Okay, that's fine. Okay, this one, this is a complex trinomial. So two numbers multiply to 30, add to 13 will be 10 and 3. Factor out the 2x, factor out the 3, and the common factor of x plus 5, and there's your final answer. This one, factor out common factor of negative 2. Again, always keep the x squared positive. Two numbers multiply to negative 80. Okay, so that'll be negative 10 and positive 8. Always keep the coefficient once you factor it out. Okay, always keep it there. Factor out the common factor. Oops, there's no x there, just 8. X minus 2. And then x minus 2, 5x plus 8. Okay, so hopefully these are the answers that you got. Okay, these will be your final answers. Okay, so these are just reviews for factoring simple trinomials and complex trinomials, okay? Now we're going to move on to the next example here. We want to factor this one right here. Okay, now this one is a little bit special because there's a 0x. So technically, we can rewrite this as x squared minus 9 as well, right? They are equivalent. But for now, we are going to keep it as x squared plus 0x minus 9. Okay, so if we want to factor this, this is just like regular every other trinomials, right, or simple trinomials in this case. We're looking for two numbers multiply to negative 9 and add to 0. Well, these two numbers will be 3 and negative 3, right? They multiply to negative 9 and add to negative 3. And because this is a simple trinomial, therefore your answer is just x plus 3 times x minus 3. Okay, so this one is not that bad, okay? I mean, again, it's a special case because the middle term is 0. And it turns out, if you look more closely, this is a perfect square, right? That's x squared. 9 is also a perfect square because that is 3 squared. So this x squared plus 0x minus 9, or simply x squared minus 9, is what we call the difference of squares. This is what we call the difference of squares. Okay, because difference meaning minus, right? There's a minus sign between of two squares, the x squared and the 9, which is a 3 squared. Okay, so this is a special case. This is what we call the difference of squares. Now we can actually factor this using, or we can notice a pattern here. You can see that this is x squared. And again, how do we get x squared? Well, that simply comes from x times x. And how do we get a 9? Well, because 9 is a perfect square and there's no middle term, so that actually comes from 3 times negative 3, or negative 3 times positive 3, right? The order doesn't really matter. So the difference of squares is the product of the sum and difference of two terms. Okay, so that's the product of the sum and difference of two terms. Sum of two terms, a plus b, and difference of two terms, the same two terms, a minus b. And if you multiply those two together, it actually gives you the difference of squares. Okay, a squared minus b squared. Okay, so when we, or if anytime we notice that we have difference of squares, we can simply just square root each term, right? Because you can see the square root of a squared is just a, and the square root of b squared is just b. If we can just square root those two terms, well, then we finished it, because essentially when you factor it, it's just going to be a plus b and a minus b. Okay, let me show you some examples here. What I mean by that is you can notice that this is a difference of squares, right? Because it's x squared minus 16, which is 4 squared. So we can rewrite this as x squared minus 4 squared. Okay, notice how I just kind of square root both terms to get the x and the 4. And once you have this done, then this is just going to be the difference between these two terms and the sum of these two terms. So x minus 4 times x plus 4. And that's how you factor difference of squares. Okay? You just square root each term and you get the result, and those become your a and b's, and then you just go a plus b, a minus b. Okay? Similarly, if you, again, this is a difference of squares because we can rewrite this as, well, the square root of x to the 4 is x squared squared. Right? If you square the x squared, you get x to the power 4. This one a little tricky because there's a coefficient of 4. So if you square root the 4y squared, you actually get 2y squared. Right? Because 2 squared is 4 and y squared is, well, y squared. So this, again, is a difference of squares. So if you want to factor this, this is going to be the sum of the two terms times the difference of two terms. Again, whether you do addition first or subtraction first, it doesn't really matter. Okay. Lastly, again, you can see that this is actually, this one is trickier because we should factor out the common factor of 4. Then you get 4x squared minus 1. And then that is a difference of squares. I mean, technically speaking, this is also a difference of squares, but we should always factor out the common factor first, right? So this can be rewritten as 2x squared minus 1 squared. Okay, because 2x squared is 4x squared, and 1 squared obviously is just 1. So then this is going to be 4 times, again, the sum of the two terms times the difference of two terms. And there is your final answer. Again, the 2x came from here, and the 1 came from there. And same thing for the next set of brackets. Okay, so that's how you factor difference of squares. So that's one special kind of factor I want to show you, or special kind of trinomial. Well, it's not really a trinomial, it's a polynomial, but a special case I want to show you. The other one that's useful to know is the perfect square trinomial. Okay, so it basically is a trinomial that's a square of a binomial. Okay, so this was a difference of squares. It's a squared minus b squared. This is a perfect square trinomial, and that really comes from, again, a plus b squared. Okay, because you can see that's a square, that's a perfect square. So a plus b, if you square that, you get exactly this. Okay, let me show you. Let me actually expand it. A plus b times a plus b, right? Remember, a plus b squared equal to that. If we expand this, we get a times a, which is a squared, a times b, which is ab, b times a is same thing as, well, I mean, ba is same thing as ab, right? Because again, if you multiply, the order in which you multiply, it doesn't matter. Okay, b times b is b squared. So then if you collect like terms, you get a squared, and ab plus ab, that means you get two of them, so 2ab plus b squared. And that's how you get this one right here, a squared plus 2ab plus b squared. Similarly, if you have a minus b, then you simply just get a squared minus 2ab plus b squared. Okay, so what we notice is this. Okay, so the moral of the story is common mistake. People think, okay, so again, don't do this. Let me write this here. This is a common mistake. A plus b squared is not the same as a squared plus b squared. This is a common mistake. People just square the a and the square the b and add them together. You're missing the middle term if you just expand like that. Okay, so there is the 2ab. So if we want to expand perfect square trinomials, it's simply you just square the first term, so you get the a squared, square the second term, so you get the b squared, and you are going to multiply these two terms, a and b, together and double it, and there is your 2ab. Okay, so if you expand a plus b squared, that's what you get. You get the first term squared plus the second term squared plus twice times the first term and the second term. Okay, I think before we look at how we factor it, let me show you an example. Okay, so for example, if you want to multiply like 2x plus 5 squared, if you expand this, you treat this as your a and you treat this as your b. So recall, this is going to be a squared plus 2ab plus b squared. And now you simply just plug in those terms. Okay, so our a is 2x, and then 2 times a times b, which in this case is a 5, plus b squared is just going to be 5 squared. So then this is going to be 2x squared, that's 4x squared. 2 times 2x is 4x, 4x times 5 is 20x, and then 5 squared is 25. So this is your perfect square trinomial. Now, if we were to go backwards, if you want to factor this, okay, and I mean, how can we recognize that this is a perfect square trinomial? Well, what I noticed right away is that this first term is a perfect square, and my last term is also a perfect square. So if you have that, there's a good chance that this might be a perfect square trinomial. So then what we do then is, well, if we square root this, if we square root 4x squared, we get exactly 2x. If you square root of 25, you get exactly 5. And because it's a plus sign here, we're going to put a plus sign here. And then how do we know if this equals to that? Well, I mean, obviously we know it is. But then what we can do is we check the middle term, okay? So what we need to do is we got to go 2 times our first term, which is 2x, and then times our second term, last term, same thing, and see if this equal to 20x. Well, in this case, it does equal to 20x, and therefore this is a perfect square trinomial. Okay, so that's how you check. Okay, you check whether the first term is a perfect square, or the last term, and if the last term is also a perfect square. If both of those are perfect squares, then you can simply square root and square root. And because that's a plus sign, so we're going to put a plus sign there, and then we can check by multiplying with the first term and the second term with a 2, okay, with a 2 here, and see if the result, if the product gives us the middle term. If it does, then it's a perfect square. If it's not, well, then it's not. Okay, so basically that summarizes this portion here. For a trinomial ax squared plus bx plus c to be a perfect square, the last term must be positive and must be a perfect square. The first term must also be a perfect square, which means again it has to be positive. I mean, you could factor out a negative sign and make it positive, but in that case, c will also have to be positive. Okay, so both of those two terms must be positive. And then it says in part C, the coefficient of the middle term is the square root of the first term multiplied by the square root of the coefficient of the last term and then doubled. Okay, that's exactly what we're saying here. Oops. You must multiply the 2 with the square root of the first term, which is 2x right there, and then the square root of the last term, which is 5, and the product must equal to the middle term. In that case, it is a perfect square trinomial. Okay, so let's look at some examples here. Is this a perfect square trinomial? Well, let's see. That's a perfect square and positive. That's a positive and also perfect square. So let's multiply 2 with the square root of the coefficient here, which is 1. Well, actually, you know what? I'm just going to multiply by 1x. Okay, the square root of x squared is 1x. And then the square root of 16 is a 4. And if you multiply these 3 terms, you get 8x, which is exactly that. This is a perfect square trinomial. Okay, let's see if this second example here is a perfect square trinomial. Well, that's a perfect square. Yes, that's a perfect square. Perfect. Okay, so let's see. We're going to multiply 2 with, again, the square root of that is just x. The square root of 25 is a 5. And if you multiply these 3 terms, you get 10x, which is not the same as that. Therefore, this is not a perfect square trinomial. Okay, it must be the same as the middle term. Okay, let's check. This is going to be, that's a perfect square. That's a perfect square. So then let's see. The square root of 2x, the square root of 4x squared is 2x. And going to multiply that by 2 as well. The square root of 9 is a 3. If you multiply these 3 terms, that's 2 times 2, 4x times 3, 12x. Same as 12x. Yes, this, I know it says minus sign here, okay, it's a negative there, but it doesn't matter, okay? As long as it's the same number, then it is a perfect square trinomial, because as I showed you earlier, what you have to do then is you're going to go put 2x, you're going to put a 3, right? That's a square root of 4x squared, that's 2x. Square root of 9 is 3, it's a squared. Because that's a minus sign, so there is your minus sign. In that case, your middle term will be negative, okay? Final example here, let's see, that's 25a squared, so that's a perfect square. That's a 9. That's also a perfect square. So let's check. We're going to multiply 2 with 5a. That's the square root of 25a squared. Square root of 9 is a 3. Multiply these three terms, you get 30a. Compare with that, it's not the same. Therefore, it's not a perfect square trinomial. Okay? So, let's take a look. Let's factor the following. You can see, hopefully, right away, that's a perfect square. That's a perfect square. And we know that 2 times 1x, that's the square root of x squared, times the square root of 25 is a 5, which is 10x. This is a perfect square trinomial because it's the same as that. Therefore, this is going to be x and 5. Again, where I get this x from, that's the square root of x squared. Where did I get 5? That's the square root of 25. Okay. This time, it's going to be a negative sign because it's minus 10. So your answer in this case is x squared minus 5. Okay. Okay, similarly, this next example here, the square root of 4x squared is 2x. I'm going to multiply that by the 2. The square root of 25 is a 5. Again, I can check whether this is a perfect square or not by multiplying 2 with the square root of the first term and the square root of the last term. And because, again, I noticed that both the first and last terms are perfect squares, therefore I can try it, right? See if it works. That's 2 times 2 times 5, that's 20x. Perfect. That's the same as your middle term, and therefore this is going to be a perfect square trinomial, and they are simply going to be 2x and a 5 for your first term and second term. It's a plus sign here, therefore it's going to be 2x plus 5 squared. Okay, hopefully that makes sense to you. This is a more challenging example. You are definitely not going to see this year, except maybe here, or if you want some challenge, I can provide you with some. But this is definitely more advanced. I will do it. If you don't quite understand, that's okay. You'll do it again next year. Okay, so I just want to show it to you. If you don't quite understand what I'm doing here, that's fine. Okay, but if you want to challenge yourself, then see if you can understand what I'm doing here. Okay. We want to factor this. This is x squared plus 6x plus 9, and then minus 4y squared. What I do notice is that this is a perfect square trinomial because x squared is a perfect square, 9 is also a perfect square, and then I can check by multiplying 2 with x. Again, that's the square root of x squared, and the square root of 9 is a 3, and if I multiply these three terms, I get 6x. That's exactly what I have for the middle term. Therefore, I can factor this. This is going to be x plus 3 squared. And then I still have minus 4y squared. Okay, so that's my first step. Now, after I finish the first step, factoring the x squared plus 6x plus 9, I notice that this is a perfect squared, and also 4y squared is also a perfect square. And there's a minus sign here. So this is a difference of squares. So I can actually change this to x minus 3 squared minus 2y squared. Again, this is difference of squares. Therefore, I can factor this. This is my a, and that is my b. So when I factor difference of squares, remember, it's just going to be a plus b times a minus b. So the sum of the two terms and the difference of the two terms. And there you go. That's how you factor this question right here. Usually, though, however, we write this because we want to write the variables first. So usually it's going to be written as x plus 2y plus 2, and then x minus 2y plus 2. But I mean, yeah, either or is fine. Okay, either or is fine. So that's the more challenging example. It's not, well, a little bit more challenging, you can see. It involves both concepts of the perfect square and difference of squares. Okay? All right, we have 4 more examples here. They are simply, finding the areas of the shaded region. So I will show you. Here we go. This is a circle. We want to find the area of the shaded region Well, to find the area of the general idea to solve for the area in this case is that we need to find the area of the circle and then minus the area of the triangle, okay? So to find the area of the circle, recall, area of the circle is equal to pi times radius squared. Well, here the radius is just r, so pi r squared, minus the area of the non-shaded part, which is the area of the triangle. Recall, area of the triangle is equal to the base times height, which in this case is also r, because that's the radius. This is also the radius, so r times r divided by 2. And we can then simplify this. Well, r times r is just r squared. Okay, and now you can see there's a common factor of r squared in both terms, so you can simply factor the r squared out, and you end up with pi minus 1 over 2 unit squared. Okay, so that is the area of the shaded region for part A. All right, I will show you part B as well, and I will let you try part C and D. Okay, for part B, similarly, to find the area of the shaded region, we simply take the larger square minus the smaller square. Hold on a second, that sounds very familiar. It's squared minus a square. Oh, hold on a second, that's a difference of squares, hey? Anyways, interesting. We can find the area of the bigger square by multiplying the side length squared, right? X squared minus, well, the smaller square, which has a side length of y and squared. Well, we can factor this, right? Because that's a difference of squares. It is simply going to be the sum of those two terms times the difference of those two terms. Okay, x plus y times x minus y, square units. Okay. Okay, C is slightly trickier. I'll give you a little hint. Obviously, you can see that part and that part added together is one full circle, okay? So, I mean, yeah, that's right. So then you can see you actually have two circles, okay? Give it a try. The C might be trickier. Hopefully you'll get it. Part D is similar to what I just showed you in part B. So I'll give you some time to try it, and I'll show you how the answers in a bit. Okay, pause the video, give them a try. Okay, so part C, like I said, is slightly trickier. What you have to notice is that you have two circles that are empty, okay, and you have one rectangle. But it doesn't show us what the side length for these rectangles, right, for this rectangle. So what we can do, though, is what we need to recognize is that the radius is r. Well, we can draw a radius this way as well. So that's 1r. We can draw another radius right here. We can draw another radius right here. And we can draw another radius right here. So in total, 4r. Okay? And if we just shift this line up, then this is 4r. Right? Now this is a radius, that's r. This is also a radius. So therefore this width is going to be 2r. Okay? So the area of the rectangle is simply going to be 4r times 2r. Okay, that's the area of the rectangle. We're going to take that entire rectangle and we're going to minus the circles. Again, we have two circles. Okay, so the area of a circle, recall, is pi r squared. But because we have two circles, so we're going to multiply all of that by 2. So we have 8r squared minus 2 pi r squared. Okay, then we can simply factor out the common factor of r squared. Actually, we can factor out 2 as well. So it's going to be 2r squared times 4 minus pi square unit. Okay, you can actually factor out 2r squared. That is your largest common factor, right? Greatest common factor. Okay, that's fine. For part D, similarly, we need to find the area of the bigger square, which is 2x plus 1 squared, minus the area of the smallest square, which is going to be x squared. Okay, so we can then, again, you can see this is a difference of squares, so then we can factor by having the sum of the two terms multiplied by the difference of two terms. Okay, so that is the how you factor the difference of squares. Now we can combine the like terms inside the bracket. We have 2x plus x, which is 3x plus 1. And we have 2x minus x, which is x plus 1. And again, square unit. Okay, so that's how you factor the difference of squares. I mean, I think the area examples are mostly the common factor and the difference of squares. We didn't actually see the perfect square trinomials here, but you can definitely factor perfect square trinomials by checking, first of all, if it is a perfect square trinomial, because if it is, then it's actually quite easy to do. It is also quite important that you know how to expand the perfect square trinomials, okay? So like this example right here, okay? I think that is very valuable. Okay, this is kind of messy right here. Let me just erase a bunch of gibberish right here, okay? This, being able to factor being able to expand perfect square trinomial, being able to expand perfect squares is actually quite useful. Okay, it actually saves you a lot of time. Okay, that's the lesson for this section, and actually that concludes the this unit. So do some practice questions and let me know if you need some help. Okay, good luck.